Hey everyone, welcome to this live stream called Welcome to Local AI. And it's a live stream about local and open AI. We're going to wait around a little bit so that everyone can join and ask questions. So if you've got any questions, you can drop them in the comments and we'll do our best to answer them as we go along. And we can also show them on screen and like answer them on screen. Don't worry if they're kind of too technical or if they're about a project that you're working on and that you want help on. That's also fun. Like, it doesn't need to be a big general question. They can just be small questions like, how do I get this thing to work on my Raspberry Pi or whatever. Sometimes those are the most exciting questions. And yeah, you can also just say like where you're from or what you're working on or what's exciting you, and we'll get them all in the comments and we'll do our best to answer them. We're also getting comments in from like each platform as well, from YouTube, from X, and from LinkedIn. So they all come in one place and we can just answer them. One question is, will this be recorded? And the answer is yes. It will be recorded on each platform, I think, but I know that it will be recorded on YouTube and you'll be able to get that. And that's the Hugging Face YouTube. Exciting questions. Daniel Han, just repeating what I said there. Great. And so once we get going, I'll introduce the team that we've got here to onboard you to Local AI, and then I'll get started. Cool. So the idea in this stream was that it was a kind of onboarding to Local AI, right? We've noticed that OpenAI, open source AI, has become way more popular in the last few months. Like, it's been building and building progressively, and it's gotten to a point where kind of everyone, like including my mom, is using open models, and this is really cool. But because of that, there's a lot of technical challenges or technical aspects that are being built around and kind of new things that are making everything easier. And so we thought, okay, let's get everyone together in one place and we'll show you kind of the easiest way to do things and to get you started. So with that in mind, I reached out to a few people that I know and work with that I thought were like really the best in their own domain. And they are Daniel Han from Unsloth, who is the author and the maintainer of Unsloth, of course. And they're responsible for many of the GGUF files that we use and that we download and that are super fast and also robust. Hey, Dan.
Hello, hello. Yeah, thanks for having me on.
Cool. And next we've got Honor, who is a maintainer of OpenClaw that we all know, an amazing tool. And Honor is specifically responsible for making OpenClaw work even better on local models, with local models. So hey, Honor.
Hi, Ben. Thank you for having me.
And finally, a legend in the space, of course, Mervyn Nguyen, who is responsible for local agents at Hugging Face and is kind of really leading this whole part of our initiative and how we get this to work with libraries like Llama CDP. Hey, Mervyn.
Hello, super happy.
Okay, so I'm going to start off with a very short introduction, and then we're going to come back to Merve, and then Daniel, and then Honor. See you in a sec, guys. Okay, so let's go through these slides. As I'm going, you can ask me questions, and my friends will help to kind of answer them, and they might interrupt me as well if the question is kind of relevant or I really need to expand on something. So I've got these slides, and I had this idea that we should really start from like the very beginning and say, okay, what are the most obvious questions that I could imagine asking if I was an outsider? And so the first question I would ask is, are open models any good? Like, can I use them? And if I use them at work, like, will my work suffer? And would that be a problem? So, okay, for this, we can look at benchmarks and we can look at public opinion. And in both of those counts, it looks like some of the latest models, like GLM 5.2, are very close to some of the frontier models in the world? So the answer to that question would be yes. You can reliably do tasks, maybe at the very edges of the longest running tasks and the most complex tasks. Then they're not going to give you the same performance, but they're definitely going to give you a good enough performance that you can apply to a lot of things that you're using daily. We read a lot about models, Chinese open source models, and so you might ask, are all these open models Chinese, and are all the closed models American? Is there some kind of opposition going on there? The answer to that is no. There are many models, open models from companies like Google, Meta, the Allen AI Institute, RC in the US, and there are also European models from companies like Mistral and Swiss AI. And all over the world, there are open models and open model labs. And in fact, because of how models work, or how open models work, we can actually download them and have them in our houses. So they're really local. They're as local as you can get. Next question was, can I use an open model without technical skills? Yes, it's getting significantly easier and easier with the release of every kind of package. And we're now at a point where there are UIs like Unsloth, but also like local, like LM Studio, and many more that allow you to just do this in a UI in a kind of really easy way. So you don't need technical skills. And then the last question, what makes a model open? Like, what are we talking about when we say this open model? Now, this is maybe a little bit abstract. So I created this little diagram. I'm a visual person, so I understand things in a visual way. And I didn't use an AI model to generate this, actually. You might be surprised to hear. And so let's say that this is an application, right? And in this application, we've got a model somewhere, and we've got an application like ChatGPT. And we're using ChatGPT, and it's communicating with that model through an API. If there was this red line on the API, behind that, we don't have access to what's behind that API. We don't know what the application is doing. We don't know what the model is. We can't access it. So we would say that that's a closed system. Now, if we had access to that model and we could download it from a website like Hugging Face Hub, and we could use it and study it and kind of reproduce it, then we would say that that was an open model, or we would say that the models were open weights. If we had complete access to everything that the model ran on and all of its training and all of its data, we would then say there was an open source model. But most of the models that we work with are open weight models, are open models, and that's what we're talking about when we say that. So a model that we can access its form and kind of download it and use it. Now, what is a local model? Well, a local model is a model that we download and then we run on a device that we own or that we rent, that we have access to. So that might be your laptop. In most cases, probably is your laptop, but it might also be a server that maybe you share with friends or colleagues that you have in your company. It might be a server that you rent from a cloud provider or something like that. But you're able to take that model and run it on your own device. Now, because of the nature of a closed model, you can't do this with all models, right? You can't do this with Fable or GPT because you don't have access to those model weights. So you can't run them on your hardware. And because you can do this with local models, it means that they have an inherent privacy because they're running on your machine and you're working with them, you're sending your data there and you're getting it back. And that data is not going anywhere, staying on that device that you own or that you rent or is in your house. So because of that, they have this huge unlock for like tasks that you might never think to do with a model, with an API, because maybe the data is vulnerable or not something you really want to be sharing. And they're also cheaper in some ways because you're not going to pay these usage fees on a monthly basis in order to use these APIs. Instead, you're going to need this hardware. So that leads us on to how we're going to do this, right? So that's the basics. And how are we actually going to do this? What library are we going to use? We're going to start off by talking about Llama CPP. And Mevi is going to join me and give a demo on Llama CPP and kind of walk you through how you use that.
Hello, thank you so much for hosting me. There is a couple of people in the comments that are saying running models on hardware is costly and hardware is the cost. to be frank, I can just run a lot of quants of which Daniel will talk about today, quants of Gemma 4, and it just works very well. And I have a MacBook Pro, so it's easy for me. At the same time, I also have a DGX Spark, and over there I run a QN 3.6, yes, and Gemma 4 as well. Although it's a bit slow because like DGX is a bit slow, DGX Spark is a bit slow, but like you can just invest for once and then just use them instead of having a subscription, which I'm going to talk about today with Llama CPP. So this presentation is called Llama CPP, what is new, but at the same time, it is enough to onboard you to Llama CPP. So let's go. If you don't know about Llama CPP, it's an open source inference engine library for running LLMs on local hardware easily. And basically, like there is model definitions and everything, and like a couple of tricks to make a generation work super fast. And it supports a very wide range of hardware that you will be surprised. Like I'm running it on my Mac, I run it on the DGX Spark and so on. And it depends on this model format called GGUF, which Daniel will talk about today. It's like a self-describing, transparent, and secure. It's just like safe tensors, if you know safe tensors, where like only model modules are serialized. So you can just download the GGUF file and use it. And when I say self-describing, it means like this file format has like headers and it describes a lot of information about the model itself, which we resurface on Hugging Face Hub. I'm going to show you. And it also comes with a bunch of supports for side things such as quantization, embedding. Also, you can serve embedding models with it, and as well as benchmarking a given open LLM. And moving forward, so basically this presentation is beginner friendly, and we want to be even more beginner friendly with Llama CPP. So moving forward, we will go higher level for a better developer experience. And starting with the single entry point binary for Llama CPP, basically you used to have Llama-server, Llama-CLI. We only have now Llama CLI, Llama Serve, and other things. And Llama Serve, if you don't know, it used to be Llama Server. It's basically an OpenAI compatible HTTP server for like when you want to serve the models, as well as Llama CLI, which is like quick generation, you just run it. And we also have Web UI, which I'm going to show today. It's basically a very nice interface for Llama Server with support for MCPs, multi-model input, and more. So like this is how it looks like. You just, once you install Llama CPP, you just do Llama Serve HF, and then you give the model ID, which I'm going to show you. So we recently shipped something called llama.app. Like you just go to your browser and type llama.app, and like over there you can see our recommended models. And in each model you have the options of the available quants on Hugging Face. And then let me go back. And then once you click run, it just copies the command, like one-liner command for you to serve it on Llama CPP. As you can see here, down there, it says copy to clipboard. And basically with this binary change, you have Llama Serve for Llama Server, Llama CLI for Llama CLI, Llama compilation, and Llama quantize. And like this is how the quantize one looks like. It's not a super big difference, but it makes things very much convenient and easy to find. And basically the hub, when you go to Hugging Face Hub, the way you should search for models is that on the left-hand side, you have the other tab. And then over there, you can pick Llama CPP, which shows the Llama CPP compatible models. But many libraries already use Llama CPP, which I'm going to come to today. So like you can also pick them. And then on the right-hand side, you can see the hardware compatibility of those models, of the quants of them. And on the right-hand side, again, you have use this model button, and then over there you can go to Llama CPP. And then you have the commands for the Llama Serve and Llama CLI as well, which you can just start the server, like copy paste, start the server with the quant of your choice. Then you will go through how to pick the quants today for your specific hardware. But basically, like one thing I'm not showing here is when you go to your Hugging Face settings, if you just enter your hardware, basically there's a section to add your hardware. Once you add your hardware, it will on every single model repository on the right-hand side, it will show you the quants of a given model that are compatible with that hardware. So it gives a lot of convenience to see which quants can I run with my model, etc. Conveniently. And once you start running the model, you can go to localhost 8080. You can also change this port if you want to. And over there, you will see Llama Web UI. And Llama Web UI is a very convenient interface to serve GGU Llama models, to interact with them. It supports multi-model inputs. It supports MCP servers, and it also has some very advanced settings. I'm walking through a bit here. Basically, you can add system prompts and stuff, as well as the generation parameters. You can set up specific agentic settings. You can add MCPs. You can add tools to it, and so on. Let me pass. I think in the middle of it, I was actually doing a small generation, but I will just pass. Basically, like I was asking for a baklava recipe, like I always do from when I'm testing a model. Moving on. Basically, Llama CPP also pairs very well with your given coding agent. Like in here, for instance, I use the Llama CPP extension of Pi, which if you don't know Pi, probably Ben will show you today. It's an open source coding agent. And Pi has a Llama CPP extension, which you can install, and then once you install it, basically whenever you launch the Pi, it will see the served Llama CPP server and then directly connect to it. And then, for instance, here I'm generating a simple website with, I think, Gemma for E4B. By the way, I really recommend this model. You can use the quants of it. It works very well. I cannot vouch for E2B a lot, but E4B is a genuinely good model. And here is the website that it has created. And lastly, we have recently shipped something called Llama macOS. It's like a Llama app. Once you install it on top sidebar, you can see for each model that you have installed, it shows the VRAM requirement for a given models. Basically, like for each model you can enable a certain context window. And because of that, each mod, like when you enable certain context window, you have additional memory requirements for that because you have the KV cache and everything. So like with this app, you can see how many memory you actually require a given model with that certain context window that you're setting up, as well as like it works for quants and everything. And then once you just click on the model, it serves, and then you can just go to Llama Web UI and start talking to the model, which is very, very convenient. This is recently, this is a very recent change. I think we are announcing it for the first time. So like make sure to try it. And I think I can take questions now since I'm pretty fast done. If you have any, of course.
Hey, nice. Yeah, we had a lot of questions flying in that we were asking them as we're answering them as we were
Sorry, I didn't
going.
see.
But that we can let some more come in, and I can kind of voice some of the ones that I recorded. So one of the main things was about cost. Like you kind of described it at the beginning, and you said about yeah, you obviously have an upfront hardware cost. Do you maybe want to like unpack that again and then go into like a little bit more detail of like what you could imagine paying?
Yeah, sure. Basically, I think at this point, like for most of the tasks, at least, you can just run like a quantization of Gemma 4 or Qwen 3.6. Especially the MOE versions of these models pair very well with the unified hardware. Like basically, for instance, a MacBook has like a unified, like the GPU and CPU share the same memory, and like because of it, like you can just run MOEs very well, and MOEs are also very fast. So you can use like quants of MOE models. They are very, very capable. So for instance, I use the MOE version of Qwen 3.6. And for Gemma, I use E4B, and like it works very conveniently on my MacBook Pro. To be frank, the quants of E4B model, and it does many of the tasks, to be frank. Maybe for long-running tasks, I don't suggest. Basically, for long horizon tasks, it can spiral at times. So I suggest using something like GLM 5.2. GLM 5.2 is like not a local model by all means. It's a large open model. So basically, there is like a difference between an open model and the local model. Like local models are open models, but they can run on consumer hardware. And GLM 5.2 is a very big model. For instance, you can use with like inference providers and stuff. It works very well with the long running tasks. For instance, like I do like some auto training pipeline for my like computer vision models, and I need to babysit the model, and like Qwen and Gemma were spiraling a bit, whereas like GLM 5.2 is like very good. So I can never answer the whole thing about what would the hardware cost, because it really depends on what you're actually doing with the model. If it's like a long running task, you should be using a relatively larger model, and in my opinion, it's good to use like from a serverless provider. And on top of it, I would say Chinese models are specifically more efficient because there is like a ongoing chip ban over there, and because of it they have to really use whatever they can, and like including the inference. So they do a lot of optimizations. GLM is not really attractive in that sense. It consumes a lot of tokens to accomplish a task, but it does the task. For instance, in artificial analysis, there is like this graph of like number of tokens spent versus like the task accomplished, the performance, and like GLM is not a good model in that sense. So like you might want to look at that graph. And yeah, like I wouldn't be able to answer this question. Sometimes my tasks are super easy, I just dump them, or like medium difficulty, I just dump them. I run my OpenClaw agent with the Qwen 3.6 quant, for instance. It does the coding stuff over there. So it kind of depends, actually.
Yeah, thanks. I mean, it's obviously a difficult question, but you've kind of like unpacked the mental model that people have to go through in order to figure out what they should use. So I feel like this leads straight into Daniel's talk, which is going to be about how we get these models and specifically like how we optimize their inference. So thanks a lot, Merve. And you're still going to be in.
I will answer questions in the comment section.
Thank you. See you in a bit. Hi, Daniel. Welcome to the stage.
Yes, let me share my screen. Okay. I will do. Okay, give me a sec. I think I got it. Oh, okay, I got it. Yes.
You're
Okay.
good. Yeah.
Yes. Yeah. Well, hello everyone. Yes. Local models are extremely powerful. And yeah, like, if you want to search for local models, the best place to go to is obviously Hugging Face. So Hugging Face. Okay, they're nearly crossing 3 million models. That's pretty cool. But yeah, like for GGWefs, you have to the left-hand side section. And the left-hand side section shows you, like which formats you want to use. And so, for example, for this, if you want to run it on your Macs, your, GPUs, consumer GPUs, but also if you want to run it on data center GPUs, GGWefs are very great. So if you click on this one, this will actually filter all of the GGWefs from the entire community. And yeah, definitely search this, list out. There's many new models, many cool models. Yeah, we also upload models from Unsoft side as well. Yeah, like for example, a very popular model recently, a very powerful and popular model is GLM 5.2. So GLM 5. GLM released 5.2. I think was it last week? And it's extremely powerful. And the biggest problem though is it is very big. It is 1.5 terabytes if you want to run this model. And so that is extremely prohibitive for most people to run. But by using some tricks, you can make the model much smaller. You can make it 217 GB. And you might be wondering, okay, you reduced, like 1.3 terabytes. Doesn't the model get like dumber? And the trick is it does not get dumber. In fact, because we, think this is 86% less space, you would think that if you reduce the model by 86%, it will get dumber by 86%. But actually, that's not correct. It only gets dumber by 14%. And so that's actually, there is tricks you can do to employ to make the model much smaller without making it dumber. And there's other models, for example, like Qwen 3.6 is a very popular community favorite. And you only need, if you want to use like a 1-bit dynamic quantization, you need around 10 GB of VRAM plus RAM. So if your computer has 10 GB VRAM, so your GPU memory plus your actual memory, so your system memory, if it's at least 10 GB, plus maybe 2 GB for the KV cache, it generally is pretty good. If you have like a 16 GB GPU, maybe the 3-bit version works reasonably well. But yeah, Qwen 3.6 is a very popular model. And so there are many other popular models like Gemma. I'll also talk about that as well. But for GLM 5.2, I said that you can reduce the model, to very small sizes without actually hampering accuracy. And we shown an example, right? So like the left-hand side is a 1-bit version of GLM 5.2. And remember the 16-bit version, which is the maximum, the biggest model of GLM 5.2, if you don't do any like, special tricks to shrink it down, is 1.5 terabytes. And this 1-bit version is only 210 GB. And we told it to create like some sort of animation of a car. It looked like it did well. We compared it to Claude Opus. We compared it to GPT 5.5. And yeah, it does pretty well. And so we show that, by doing these special tricks, to make the model as small as possible, we do not make the model dumb, right? It doesn't generate gibberish or useless code. It actually works. And this example was just one shot, right? We didn't need to tell the model to fix bugs. We didn't need to manually edit the code. The model just worked very well. And so this methodology, we call this dynamic quantization. But many community members in the entire community, they also employ some methodology of dynamic quantization. And we show many benchmarks of doing dynamic quantization. Generally speaking, you want to reduce the disk space of your quantization, but also to reduce the KOR divergence. between the quantization and the bfloat16 version. The Carrera divergence is just the distance between the quantized model and the original model. And you just want to reduce this distance as much as possible. And so, we have some research, you can read this out, about every single model, from Qwen, Llama, Mistral, Google's models, Microsoft's models, everyone's models can be quantized down. And the trick of this is because we quantize them down, it can now run on your local device. And yeah, there's lots of plots that we show about this. And we actually, if you search on Unsloth fonts, we actually have a lot of these fonts that you can play around with. GLM, Diffusion Gemma is very cool. Kimi's, models, Minimax, Qwen, Gemma. We have a lot of models, NVIDIA's models. Yeah, so if you check out this page, there's a lot of these dynamic fonts that you can run locally on your computer. And yeah, Qwen 3.6 is very, very popular. So if you want to make actually faster inference, right, you don't just want to make the model smaller and smaller. So there is something called MTP, where you can essentially make your inference 2 times faster with 0 change in accuracy, right? It doesn't actually reduce any accuracy. All it does is it makes your inference faster. And we show some plots, for example, how many tokens per second. This is 2 times faster for Qwen 27 billion. And for 35 billion, it's also around 1.6 or something times faster. And by enabling MTP, you can essentially make your inference faster. And remember, there is 0 reduction in accuracy. And if you want to learn, why there is 0 reduction in accuracy, we have some guides and material on that as well. So definitely enable MTP if your model supports it. And yeah, Qwen is one that supports it. Gemma 4 also supports MTP as well. Gemma 4 is very, very popular as well. So we showed, I think we showed the benchmarks previously before, but Gemma 4 is an extremely powerful model. They come in many, many sizes. The smallest is a 2 billion active, then it's 4 billion. And recently Gemma also released a 12 billion model. But also, Gemma 20, there is also 26 billion and the 31 billion. If, generally speaking, if you have a local device, I would probably run the 26 billion because it is an MOE model. So definitely, MOE's models are much faster to run on your local device because only 4 billion parameters are activated every single forward pass. The 31 billion is every single 31 billion parameters are activated. So maybe 26 billion and 31 billion are not that, they're pretty close, but actually Gemma 4 26 billion, I would say is around 31 divided by 4. So maybe 4-ish times faster at least. So, this model, you should probably run on your local device. Yeah, but Gemma, 31 billion definitely is much more smarter. Gemma 4 also has MTP, which they recently, so Llama CPP also recently just added Gemma 4 MTP support. So you can get, 2 times faster for Gemma 12 billion, two times faster for, Gemma 31 billion. And also Gemma 4 released QAT. So, you can even get even faster. And, accuracy is not that much degraded by using these QAT quants. And yeah, so definitely check out Gemma 4's QAT plus MTP. It's pretty cool. Kimi is also a very large model. So Kimi is also very popular. And if you don't want to run the full model because it is very, very big as well, you can essentially run a quant, a lower precision model as well. And we show with some research that you can do some tricks as well to quantize the model down. And we show that the perplexity and the Carrera divergence only degrades by very little. And you can recover a lot of space. So you can essentially reduce the space by 50%. And the Carrera divergence only increases by a little bit. So yeah, so Kimi also works very well. And the latest release from Gemma is Diffusion Gemma. Definitely check that out as well. I think Ona is going to talk about Diffusion Gemma as well. But Diffusion Gemma is a very cool model that is also supported on Llama CPP. If you use a pull request, but this is also very cool. It shows that you can essentially create a Flappy Bird game or whatever whatever thing you like to do using Diffusion Gemma. And I guess I will give a mini demo of, Gemma for, 26 billion. I guess we can just do like create a Flappy Bird. This is live, so hopefully this works. Let's hope. And so essentially what we can, oh, okay. I'll have to reload it. I guess this broke. Let me reload it. Is it? Okay, wait, okay. Maybe I should. Oh, yes. Okay, let's see. Does this work? Okay. It's reloaded. Okay, this is actually Hugging Face's models that are selected. Okay, that's fine. But okay. So if it's a very small model, you generally will not actually create a hug. The Flappy Bird game doesn't really work very well because this is a 135 million model. So you will need to ask the model to fix bugs, right? Fix bugs in the model. This is a very, very, very small model. So generally, it might not do very well. And so that is why we'd recommend people to use, for example, like bigger models, like Gemma 4, for example. And if Gemma 4 it should work very well. So let's wait for it to load. Yes, if you make a new chat, let's try again. Create a Flappy Bird game in HTML. So most likely this will work very well. And Gemma 4 is very cool because you can toggle thinking trace. And just like Claude and Codex, you can add tools to it. So Llama CPP's web UI also has this as well. You can add web search, you can add code execution, and you can also actually play the game. And so, okay, I think you have to press space. Oh, there we go. It's not click, but it's space. But you can see that local models actually do work well. And they're not dumb at all. I guess that's all from me.
Hey, Daniel. Yeah, that was really cool. Thank you for taking us into the details of everything and kind of giving us a tour of the whole ecosystem there and all the work that you're doing to make those model weights accessible. That's probably something that didn't necessarily come across, but when these labs release those models, they're typically in a single format or maybe a few different formats. And there's a process to get that into GGUF so that the community can use those on various different hardware, and that is basically what you've been doing, right? And that's really cool. Okay, so I'm going to move on now. Thank you very much. I'm going to move on now to my talk. Okay, and you'll be in the comments, right?
Yes, I'll be in the comments and answering people's questions. Yes.
Cool. Thank you. Okay, so I'll go back to my slides. So what I wanted to just go back to were just how we would use these with code agents. So most of us are probably using code agents already, things like Claude Code or Codex, Pi or OpenCode, these kinds of tools. And as you'd expect, we can use open models and local models with code agents. I'm going to show you, first of all, how we can just use open models. I'm going to give you what is basically an easier introduction to that. And then Honor's going to come back and show you how you can combine code agents with local models, right? So, okay, let's say it's kind of day one in your open model journey, and you're already a Claude Code user. Well, you could connect Claude Code directly to your open model, right? So you would need to go to Hugging Face Hub, and you would have to get your token. I'll just show you how we do that. So great. So yeah, we go to Hugging Face and site, obviously, yeah. And we need to find an access token. And so once you've joined the hub, you'll be able to get these access tokens. Need to give my buzzword. Sorry about that. Should have been more prepared. And you get all these access tokens, and you can manage them all here. And I would definitely recommend that you manage them, and you kind of disable them when you don't want them anymore, and you create a new token. And one of the great things about tokens is that you can actually manage what they can do, like the roles that they have. So I would definitely recommend that you do that, and that you just say make calls to inference providers. And what's inference providers? Well, inference providers are a local model running on Hugging Face. And so you can connect your coding agent to a local model running on Hugging Face. And that's the first example. That's the one that I showed you here, right? So you connect you get your token and you put it in your terminal. And then next, you would do this. HF extensions, install HF Claude, and then you can start up Claude like normal. And it's now connected to an open model running on Hugging Face. So this doesn't require any hardware. You haven't used anything, but you can go and try a model right away, which is probably the easiest thing that you can do if you really just want to try an open model. Full disclosure, there are other tools that do this as well. So let's just take a look there. Great. So, okay, now we're in Claude, or at the moment we're now in HF Claude, and we've started that up. And what you'll see here is that it exposes all of the models on Hugging Face. So I'm going to take ZAI's GLM 5.2 that we've all been hearing about. It's really great. I can select the inference provider that I'm going to use. I could say auto, and it will just choose the best one. I'm going to say Fireworks AI. And now I'm in Claude Code, but you'll see that it doesn't say like Opus here or something like that. It says ZAI's GLM 5.2. And that's really what it takes to get Claude Code running with an open model, right? It's just a case of swapping the two over like that. And you don't necessarily need to go to the local model world. Okay, that's pretty great. And what you're going to experience from that is that it will work a lot like Claude Code, which is a really great product and a really great tool. But it's also adapted to Anthropic models, right? The two work kind of hand in glove, and they work really well together. And what you could expect is that the experience will be different. It won't be the same model that you've been using, and you might need to get used to that. Now, in my opinion, what I found is that other harnesses are actually a bit more adaptable to open models. And I've appreciated kind of exploring other agent harnesses beyond the kind of standard ones. And by exploring those other ones, I'm able to get even more out of local models and open models because they offer just more customization. So I want to show you a few other harnesses that you could try. So here's a first one. It's called Pi. And you can connect it to local models in exactly the same way. There's a command for models, and you can connect it to inference providers, or you can connect it to a locally running server. So let me show you the snippet that I have for that. So if you go to Pi, it looks something like this. It's a little bit more complicated. You need that Hugging Face token again if you're running it on the cloud. And you need to define this settings.json, and then you can do this model again. Let me show you that, how that works. So you say model, as I have done here, and then you can select through your model. Okay, and another one would be OpenCode. This is another example. This has a slightly different setup. You can do HF auth login, and you can log into Hugging Face, but you can also connect OpenCode to different providers. So if you look in here, you'll find Hugging Face, but you'll also find other providers like Together. You might even find ZAI's own one, and you can connect these through this terminal to these providers. You can then do models, and you can switch between the models that you've exposed. So I have two different providers here, like the default one, OpenCode, and then Hugging Face, and I can see all of the Hugging Face models in here, and I can swap those out, and then they're exposed in there. Now, let's go a little bit deeper, and I was going to get just set up like a kind of simple task and see how that works. So if I say, describe this repo and what it does, and I drop in the unsloth URL, and it will get to work. And then I can have a look through, yeah, it's working there. So, and then I can go and have a look at some other repos because I started these off a little bit earlier. So you see Pi has been working through this, and it does some basic like file operations here. Like it it looks for the files in its directory. I'm working in this directory called live stream local. It finds what it can, it echoes through it, and it does your basic kind of agentic things in a pretty simple way. And then it gives you this like report back with this kind of structure. Let's stop there and see what Claude did. So, okay, Claude didn't kind of give us as much information. It did this fetch, and it doesn't seem to have done any read operations. But in general, it has like a broad strokes overview. It's qualitatively different, I would say, even though it's the same model, which is kind of interesting. Yeah, so like this is core and studio in Pi, and this breaks it up kind of functionally. So there's definitely difference there. Let's now take a look at OpenCode. So that actually gets the same kind of overview as Pi, but slightly different. And one thing that I would specify about OpenCode is that you get this really powerful UI with a lot of / commands that you can use to kind of customize your flow and have like certain commands and go into subagents and fork everything. And there's this sidebar here which explains a lot. I would say it's probably one of the like richest UIs in the harness. And so if that's the kind of way that you like to work, it would be a good choice. And Pi, I would really say, is like the sharpest kind of harness. Like it's kind of minimal in some ways, but it's because of that really practical, and it works quite well with like loops and kind of when it's wrapped into other kind of flows because it's quite simple. It has an exec command that's pretty useful. But the main takeaway from this is that we can see like a qualitative difference in each of these harnesses from their in the responses that they give. Okay, let's now just try something else and see how does quantization work in Unsloth? No, wait. Sorry. Yeah, and then let's see what we get. How does quantization work in Unsloth? See what that looks like. So, okay, I think, yeah. So we get the same kind of thing, and our UI is different there. And Pi is working through it. But ultimately, what you can expect is that these two models are running on the same server. They're both running on inference providers, specifically Fireworks. And they're the same models, but they're wrapped in different harnesses. And so because of that, they have a different set of tools exposed to them, and they're going to use them in different ways. The takeaway that I would give you is to go and try Pi and OpenCode on your tasks and see what they look like and see how they work for your tasks. So here we go. Claude has already come back. It's given this pretty rich report about Unsloth and how it works. QLoRa and that part of it explains FPA training. I mean, a big part of Unsloth's code base is training. So it's definitely focusing more on training than on quantization. And it's giving this overview as a table. And let's see, okay, so Pi has replied iteratively, but in general, like a lot of the elements are similar. Okay, so that's my overview of how you can connect harnesses to open models. And next, Honor is going to build on that and show you how to connect OpenClaw to a local model. So I'll bring Honor on stage and first. Hey, Honor, how's it going?
Great, Ben. Thank you for the presentation.
No worries. I hope that I've warmed everyone up to your talk, which I think is going to go into a lot more detail than mine. But hopefully people are kind of ready to go and excited to use local models.
So today, okay, let me try to share. I'm not sure if it's visible. So if you can someone tell me if now my screen is showing. So I'm on Mac. So I, like Marva, I own a MacBook and a DGX Spark, but I want to empathize with the majority of our users who have not probably paid. I mean, we are in a circle. Some people have bought a lot of Sparks recently, but I want to target people like who have MacBooks and who have 32 gigabyte unified memory in order to be able to run the Qwen and Gemma MOE models. So I am today using LM Studio. You could use VLLM Metal. You could also use, I think, Llama CPP. I'm downloaded specifically the MLX weights. If you go here and if you search for Qwen, you will see a lot of things. So this, I can empathize for the average user, is super scary. Not only you see 3 from Qwen, not only you see so many staff picks, you see all the other condensations released by others. So we definitely need a recommender that is smarter than that and which collapses the options to a more manageable list. Because even as when I first started get into this more and more, I was confused. It takes some weeks to get a feeling for what the right model is, and you need to look at the number of weights. So you have like 4 billion and 8 billion models. If you have 32 gigabyte or 64 gigabyte memory, then I would recommend, unless you are like doing a specific task, if you want to use an OpenClaw, I would recommend you to just go for the mid-sized, and mid meaning 20 to 40 billion. So now there's like a sweet spot which has been really popular, and it is 20 billion to 40 billion parameter, especially the MOE ones, which have, I don't know, 3 to 4 billion active parameters. And you go here, and if you're on an Apple, you just choose the MLX quantizations. And the smaller you choose, as you can see from here, the smaller, like Daniel explained earlier, you lose precision but gain a lot in performance. And that's the MLX variant is optimized for running on an Apple device. You choose this, and I load it basically. It's already loaded in memory, and you can click this button to customize your various settings. So it shows you it supports the model. Model car says it can support 260K tokens. Generally, it degrades after 100K. So in practice, I set it to 64K, and I set maximum concurrent predictions, which means how many sessions I'll be able to run with Qwen 3.6 on my machine. And basically, these two are the levers. The bigger your context length, the longer you can have a conversation before it needs to compact, which is very useful. I'm not, today LM Studio has made it very easy, but as you get into this, on my DGX Spark, I am using VLLM directly, and I'm setting like specific options. So we are right now at the frontier, like at the cutting edge, and the user experience, there's still some time for it to catch up. So what I'm showing right now is not the only way to run inference, but this is currently one of the easiest ways. You go, I set this model, and if I go to my machine, you can already see, my monitor, you can see I'm already filled up 80% of my 64 gigabyte unified memory. And let's do a fast benchmark, like very quick one. I have built this tool to show how you could generate So this is actually pretty good. We are getting around 30 tokens per second on this, which is faster than my earlier tests. I don't know what maybe. So what we are having is right now we are having the 35 billion sized MOE model, quantized and optimized to run on Apple Silicon, generating 30 tokens per second, which is comparable to what you have in ChatGPT, right? Depending on whether you're using Codex or Anthropic. So it can go up to 50-60% if you're using like OpenAI models. This is like already pretty compelling. Like you could use this. This is currently, let's see how much memory it's using. Well, it's using 90% of the GPU, and Apple reports doesn't report just reports a percentage. So you can see it's using it fully. You can let me stretch it even more and try to run it with 8, and I think it will have like of them will have a problem, and I can already feel my laptop going very warm. So I will kill the demo, and I will quickly check. Okay, so earlier I had an issue because I was running this demo, and I thought Google Meet was affected by it. So just wanted to demo how many AI agents you can run concurrently. This is important if you're doing work in parallel. If you are chatting up with many agents, if you're juggling context switching, you would be able to easily use 4 agents at a time, or you will be able to spawn 4 sub agents in your instance, or process a queue with like 4 tracks, whatever you're processing, 4 chat sessions, just constantly working. We recently released a blog post on Hugging Face blog about so if you go to Hugging Face blog, you will see that we are using it to create a notifier, a router system for me to get notified about like OpenClaw PRs. Directly notifies me as soon as a PR is opened, and that is using a local Gemma or Qwen model, for example. And I basically have a OpenClaw gateway running, and it is currently using the same Qwen 3.6, and I put it in a container just in case, because it's a local model and you're being secure. So one thing you need to know when you're running a smaller model is the smaller models, there's a privacy security trade-off. So you're running it locally and your data is not going to OpenAI or Anthropic, but the smaller model also means it could get prompt injected. There's a higher likelihood. So this, of course, needs like more evaluation and benchmarking. But I won't go into the weeds of how Codex auto exec works, where it creates a tool call, and the tool call gets filtered by an LLM. So you have like an LLM filtering the tool calls. I believe in the long run, it's strategically very important for local models to be able to prevent prompt injection, data exfiltration, etc. attacks as efficiently as Codex, for example. So let's ask what are the trending models on Hugging Face? Am I running out of time, Ben?
I was going to say, yeah, we could take some questions or move into comments, but we don't have a clock on this. So like, if you've got one demo you want to show, then yeah, just share it.
So I was just showing it. So I don't have a live. Yes, you do. So you have Qwen browser control is blocked. So this is running on my machine, and if you go to LM Studio and then OpenClaw box, you can see the exact configuration options. You can also tell your OpenClaw to configure yourself with LM Studio locally, and you can also do the same for Llama, Llama, Llama CPP. Yeah, the providers should be all there. So it says most downloaded models, and I can say very quick demo. I will just say, okay, write a story, spawn 3 sub agents for each of them to write a story of 1 sentence, then report them back to me. By the way, Ben, you might have an audio. There's a click being coming up in the audio, like a rhythmic. I'm not sure if it's physical or software. Now it's stopped. I think you're muted. So it's running. So now you can see the Qwen 35 billion model actually spawning sub agents. It's calling Kokoro. DeepSeek. Is it? It's basing the story on the most popular models, which is fun, I guess. Should we wait for the final story?
I don't think we have to, because we've got a few questions coming in and a lot of stuff to like wrap up, and we're at time basically. But Daniel's done a really cool job. So if you want, Onur, you could just have a quick look at the comments to see if there's any questions that relate to your talk, and I'll give like an overview of all the stuff that we said at the same time, and kind of call it a day from there basically. Does that sound good?
Sounds good. If you want to stop me from sharing.
Yeah, no worries.
Yep.
Okay. So, right, we've learned a lot in this 1 hour stream, and I'm just going to give a kind of overview on everything that we went through. A lot of it is just available on Hugging Face Hub, Unsloth, and this site, Llama app, and so you can go away and try it out. This is definitely the first place to come. It's the URL is Llama app, and it's a site for Llama CPP that just shows you how to get started. Basically, if you just run this command in the terminal, you can install Llama CPP, like Merve showed you, and you can use local models. There's also an example here of how you install Pi, and you connect it to the same the server, and this will just work out of the box without anything. So you can try that, and you can use Pi, which I showed you as a coding agent. So that's your kind of 2-step approach to having your own coding agent, which is what we've all shown you. The next thing I showed you, which is kind of even easier than this, is inference providers. And inference providers, as I said, is a way to use an open model running on a server somewhere. So it's kind of halfway between a closed model and a local model, in that you don't need the hardware. We've got a lot of documentation on this for all major coding agents and kind of integrations that you would want, and all the documentations are here in this inference providers docs. We've also got this table, which is Hugging Face hf.co inference models, and this is an overview of how much you pay per token for all models on inference providers. So you can kind of figure out which one you want to use. And we also have these handy little tags, so you can say fastest or cheapest, and you can get the cheapest model. Onur mentioned this blog post. We got local models to triage the OpenClaw repo for free, which is a cool new blog post, and basically goes into a lot more detail on what he spoke about, and is a great read. I would recommend that. And Daniel also went into that, many references from Unsloth docs that you should also check out, like running MTP models. There was another one on how dynamic quants work. Here we go. Yeah, there's a lot of like research, but also like really usable examples that you can get here in the Unsloth docs. So I'd go and check that stuff out after the call. Does anybody else have any questions or comments from the that they want to like bring up that they thought were really interesting and kind of answer out loud? Just let me know. I've got a few here, if not.
I've heard, I have seen someone ask about the demo, PyDemo one. It is actually I'm posting about it on Twitter. I need to create a YouTube account. I cannot post a comment, but if you search for local Pi, if you go and look into my profile, it is in the local Pi repo, and there's a skill in there called PyDemo Grid. You can use that.
Okay, we'll put that in the. All right, yeah. So that's like the grid that you use to create the demo. We could put that in the description of the video. That's pretty easy, so people can check that out afterwards. Cool. Did you have any questions that you thought were really interesting, Daniel?
I think I tried to answer as many questions as I could. I think, yeah, many people are excited about local models. How do I find MOE models on Hugging Face? Oh, that is a good question. Is there a way to filter MOE models? I actually don't know.
I don't think
I guess
so.
you can do like -A maybe or something. I guess you could search -A on the search. It's pretty cool.
Yeah, I mean, the thing about the hub is that it's so hackable that you can kind of do anything with an agent, but you'd have to go into the transformers metadata to get that kind of architecture information. That would definitely be a cool project, right? Like
maybe someone in the community. Yeah, someone in the community should do that. Like, showcase, filter owning the MOE models or something. I don't know, but that sounds cool.
Yeah, nice.
But I think everyone's cool questions. I guess I'm always stuck in a loop. If there is a new model. Yeah, that is true. Every single time there is always new models. So you do need to update your local stack to come with the latest, the latest and the greatest. But that also happens with, closed models, GPT 5.1, 5.2, 5.3, 5. Every single time there is a new update. 4.5, 4.6, 4.8, maybe this 4.9. So local models, you also do need to update it on your computer. If you want to get the latest and the greatest. So, it's not every week. I guess, if it works for 1 month, stick with it and then switch next month. But if you want to be at the edge, yes, there is models every day. So try them all out, I guess. Yeah.
Yeah, I mean, it kind of comes in two sides, really, because there might be more friction, you could say, or more choices, more control that you get over a local model. But once it's set up and it runs, it will be stable as any kind of software for as long as you want it, because you own those weights, right? They're on your machine. There's nothing that can happen to them. So if you're running like an application on top of it, you can just leave it there and you don't need to worry about that. But if you do that with some kind of API, the model might be deprecated. It might go through some kind of changes, and you'll need to monitor that. And because you're kind of bound to that API, jurisdictions might change, laws might change, and you're kind of stuck there. So one of the things is, you take on this, you take on control, but you get back like, a lot of reward. So, okay, I feel like we should call it a day. I'm going to double check the comments over the next hour, and I'm going to come back tomorrow as well. So feel free to just ask more questions in comments on any platform, and I'll continue to answer. It's been a really fun stream, and maybe we'll do it again. Let us know in the comments if it was useful to you and you think we should do it again, and we definitely will. Great. See you all.
Thanks, everyone. Yeah, thanks a lot.
Thank you, everyone.